going back to our so the histogram of MEDV reveals a skewed distribution. It is skewed, and we can sometimes transform the output variable to log MEDV to improve results of a linear regression predictor. And the box plot shows the side by side comparing the distribution of MEDV for homes that border the Charles River or not. And then we see that not only is the average MEDV for river bounding homes higher than the non-river bounding homes, but also the entire distribution is higher. The median, the quartiles, the mean, and the max. We can also see that all river bounding homes have MEDV above $10,000, unlike non-river bounding homes. This information is useful for identifying the potential importance of this predictor, the CHAS, and for choosing the data mining method that can capture the non-overlapping area between the two distributions. So box plots and histograms applied to numerical variables can also provide directions for deriving new variables. For example, they can indicate how to bin a numerical variable. Binning a numerical outcome in order to use a naive Bayes classifier, or in the Boston housing example, choosing the cutoff to convert MEDV to cat MEDV. Then finally, side-by-side box plots are useful in classification tasks for evaluating the potential of numerical predictors. This is done by using the x-axis for the categorical outcome and the y-axis for a numerical predictor. Next, let's add a new code cell here. It's just the same, however, its formatting is, or its layout is different, with some colors and with no grids on it. Let's add another code cell, and let's make another box plot to show a side-by-side box. So here we have a box plot for NOx, for LSTAT, for PP ratio, and for induce side-by-side box plot. For NOx against CAT-MED-V, LSTAT, and against CAT-MED-V for PP ratio and for induce. And we have that side by side. These are for exploring the CAT-MED-V output variable by different numerical predictors. So in a side-by-side box plot, one axis is used for a categorical variable. So that is in our x-axis. That's the CAT-MED-V. That's a categorical variable. And the other, for the y-axis, you have a numerical variable. So we plot a categorical outcome variable, and a numerical predictor compares the predictor's distribution across the outcome categories. So we plot a numerical outcome variable, and a categorical predictor displays the distribution of the outcome variable across different levels of the predictor. So in short, we use the categorical variable, the cat-med has its a categorical variable again because it has categories. Its value are in category 0 and 1. 0, there's a meaning, no, with a 0 and the 1. And the numerical are the NOx, the LSTAT, the PP ratio, and the induce because their values are in numbers in numerical forms. So in this example, we can see the effects of the numerical variables on the categorical variable. So later we will be using this categorical variable in prediction. So we will see here the distribution of the numerical predictors. So the categorical predictor uh, will be our uh, will be the variable that we will predict later in our prediction in our data mining tasks. So we will see here how numerical and the categorical variables are associated with each other. So we can see that the pairs that are most separated are the PP ratio and the indus. So that means they are potentially useful predictors. So next, we will show you different plots that we can make using Python, and then we'll proceed to